Okay, so a lot of us are struggling with the converse of the Pythagorean theorem, but we have a good solid understanding of the triangle inequality. So I'm going to show you how to do it forwards, and what's happening in the quick question is you're going backwards. So the Pythagorean theorem, the converse of the Pythagorean theorem, says that if a squared plus b squared is less than c squared, you have an obtuse triangle, meaning one of the angles is greater than 90 degrees. If a squared plus b squared equals c squared, you have a right triangle. That's what we've seen before. There's a 90-degree angle. And if a squared plus b squared is greater than c squared, you have an acute triangle. All angles are less than 90 degrees. So what we can do is if I give you a triangle, you can tell me whether it's obtuse, right, or acute. So let's try that. Let's say I say the triangle has sides 2 feet, 5 feet. Actually, let's do 2 feet, 2 feet, and 2 feet. All three are 2 feet. And I want to know, is this obtuse, is it right, or is it acute? Well, I'm going to plug it into a squared plus b squared. Here it doesn't matter. Typically c is the biggest one, but these are all the same. So you have 2 squared plus 2 squared. That's a squared plus b squared. And then 2 squared, that's c squared. Two squared plus 2 squared is 8, and 2 squared is 4. So I know that this is greater than this. I know that a squared plus b squared is greater than c squared. Since a squared plus b squared is greater than c squared, I know that this is an acute triangle. I know it's an acute triangle. The second thing we learned, or the thing that we learned last semester, was triangle inequality. And that says that the sum of two sides is always greater than the third. And that needs to be true as well. So if you try it with this one, 2 plus 2 is always greater than 2, so you know it exists. So what you're doing in this quick question is, instead of me telling you this piece, instead of me telling you the 3 lengths of the triangle and you doing the math and finding out it's acute, you are going to come up with the 3 lengths. Then you're going to try it out. And if it matches obtuse, you're then going to see, well, does it match the triangle inequality? So does it exist? So here are your steps. Step 1, come up with 3 side lengths. Step 1, come up with 3 side lengths. Step 2, calculate a squared plus b squared and c squared. Is it obtuse? If it's not, go back to step 1. If it is, go to step 3. Step 3 says, does the triangle exist? Meaning a plus b is greater than c, a plus c is greater than b, and b plus c is greater than a. If your answer is yes, you're done. You've come up with 3 side lengths that make an obtuse triangle that exists. If no, you're going to go back to step 1. Now, you'll probably notice some patterns that'll help you guess the 3 numbers, but from the beginning, you might have to start just randomly. So you're going to come up with 3 sides. Is it obtuse? Use the converse of the Pythagorean. If no, try again. If it is, does it exist? Use triangle inequality. If no, change your lengths. If it is, you're good. You've come up with 3 side lengths that make an obtuse triangle that exists.